As winter draws near and the temperatures fall in Illinois, it is inevitable that snow will be coming soon. Stores have decorations of snowflakes hanging from the ceilings and on windows. Holiday decorations and food products begin showing images of snowflakes. Have you ever wondered if those images of snowflakes are correct? It has been said every snowflake is unique, so if there are an infinite number of ways to create snowflakes, is there a correct way to make one? Some of these questions, and a math professor from my college years, led me to an inquiry into the story behind the snowflake. This digital story will provide some background on snowflakes and help clear up some myths surrounding snowflakes. You may be surprised that not all the advertisements and decorations you see correctly portray snowflakes. Let's begin with the question, where does snow come from? Professor Kenneth G. Liebrecht of Caltech describes snowflakes and snow crystals being made of, quote, ice and pretty much nothing more. A snow crystal, as the name implies, is a single crystal of ice. A snowflake is a more general term. It can mean an individual snow crystal or a few snow crystals stuck together. Professor Liebrecht continues by stating, snowflakes grow from water vapor. When water vapor freezes, you begin to form a snowflake. Snowflakes are not frozen water. That is called sleet. Water molecules, as most of us know, consist of 2 hydrogen atoms and 1 oxygen atom, commonly referred to as H2O. Have you ever wondered what water looks like? Based upon the structure of the water molecule, which you see here, the red ball represents the oxygen atom and the gray sticks represent the hydrogen atoms. Do you notice any distinct shape when you look at the water molecule? If you said hexagon, you are correct. Water molecules form hexagonal bonds, and thus when water vapor freezes, this basic structure is the base shape for all of the different types of snowflakes. Did you know there are many types of snowflakes? When it snows, the temperature and humidity are the main factors involved that produce the various types of snowflakes. So Professor Liebrecht provided this chart that reflects the conditions necessary to produce the different types of snowflakes. As you can see on the morphology diagram, the temperature is decreasing to the right and produces more complex snowflakes around 3 to 10 degrees Fahrenheit. When temperatures are warmer, we notice the needles that end up on our windshields. This is what we'll see near the beginning of winter. Also, when the temperatures are very cold, the snow is mainly in the form of the basic hexagonal prisms and are usually very small flakes. That's why it's so dry and not easy to pack. So for most of this digital story, I want to focus on the, quote, pretty snowflakes, or the complex dendrite snowflakes. Dendrite just means tree-like and means that it had a lot of time in the cloud to form. So how does a fully formed complex dendrite snowflake begin? Professor Liebrecht has provided this chart to show how a tiny hexagonal prism forms into a complex snowflake. Based upon the hexagonal structure of a water molecule, snowflakes begin as tiny hexagonal prisms, and given the correct temperature and humidity, the little prisms are tossed up and down in the clouds and begin to form the branches. The branches take shape based upon the conditions in the cloud. Conditions include temperature, humidity levels, presence of dirt, other snowflakes to hit, etc. So given this complex history, it is highly improbable that anyone would ever see 2 identical snowflakes. Since the snowflake experiences the same conditions as it is tossed up and down in the cloud, each one of the branches of the snowflake are shaped similarly, and thus the snowflake looks symmetrical. However, the snowflakes you see displayed throughout winter should have 6 or 12 points. So the slides you're seeing right now are examples of complex dendrite snowflakes. We could continue the discussion about snowflakes for a while. However, the point I am trying to make in this digital story is that a fully formed complex snowflake should have 6 or 12 points. Throughout my courses, I show students this information, and then we create correct snowflakes by folding a piece of computer paper into a hexagon. Once we have folded the paper, students design their own unique snowflakes. We all begin with a common shape, but they always turn out different, just like in real life. There's more math involved than you think when you look at a snowflake. And remember, snowflakes should not look like this, or this, and you think these are correct snowflakes. Count the points and see for yourself. Here are some of the snowflakes my students and I have created over the years. Students have always impressed me with their creativity. Who knew you could bring art into the math classroom? Given this information, look around this winter season. See if you can identify some of the snowflakes displayed. Do they have 6 or 12 points? If not, then the complex snowflakes displayed will not be found in nature. Although trillions and trillions of different snowflakes exist, a fully formed complex snowflake will not have 4 or 8 points.